Questions 11 through 20 on the 2004 Grade 12 AMC 12B. All the students in an algebra class took a 100-point test. 5 students scored 100, each student scored at least 60, and the mean score was 76. What is the smallest possible number of students in the class? So we have 5 students that score 100, and then we have the remaining students. If the number of students, let's say, is n, the remaining students would be n minus 5, and they score a certain amount. Now, the lowest it could be is 60. If everybody else scored 60, 60, 60 like that. So let's see what that gives us. That's the extreme case scenario. And then we're trying to figure out a mean here, so you divide by the total, which is n. And that, they tell you, is 76. So if you do the math here, you get 500 plus 60n minus 300 is equal to 76n. And this will be 200 is equal to 16n, and therefore n is 12.5. Now n represents the number of students, so it can't be 12.5, but it can be 13. We can go a little bit higher to get a full integer value. And this is basically the smallest that n can be. And you can verify that this works by plugging in n equals 13 into this equation. 13 minus 5, and I don't know what the average is of all the other students, but we'll figure that out. If you do this, you'll find that this works for x equal to 61. So basically, the students who did not score 100, their average was 61, and that's how you end up with a total of 76 as the mean for all the students. So number 11, the answer is D. In the sequence 2001, 2002, 2003, ... each term after the third is found by subtracting the previous term from the sum of the 2 terms that precede that term. For example, the fourth term is 2001 plus 2002 minus 2003, which is 2000. What is the 2004th term in the sequence? So we have the nth term, and we will figure out, let's see, how many do you want to do? We'll do 10, and then we'll see what kind of pattern exists. Hopefully we'll get a pattern sooner rather than later. And then we can extrapolate that to 2004th term, which is what they're asking in the question. Well, the first 3 terms they actually give us, 2001, 2002, and 2003. And the 4th term they also give us, but they show us how they did that. They took the first 2, added them, and then subtracted the 3rd term. So that gives us 2000, and that's basically the pattern we have to use throughout this question. So the next term, our 5th term, will be 2002 plus 2003 minus 2000, this guy right there. And if you do that, you get 2005. All right, let's just keep going here. For the 6th term, 2003 plus 2000 minus 2005, and that gives you 1998. 7th term, 2000 plus 2005 minus 1998, and that gives you 2007. And then keep going, 2005 plus 1998 minus 2007, and that gives you 1996. The 9th term, 1998 plus 2007 minus 1996, and that gives you 2009. And one more, 2007 plus 1996 minus 2009, and that gives you 1994. So I see a pattern here. For the even ones, when the nth term is an even term, in terms of its number count. It's 2000, then goes down to 98, then 96, 94, like that. And then for the odd ones, it's 2005, 2007. It's going up, actually. Now, we want the 2004th term, right? So that's obviously even. So we want these guys in terms of the pattern. We want to follow that pattern right there. Now, is there some sort of a mathematical formula that I can get when n is a certain number? The value of that term will be a certain number. So, for example, for n, let's see, what do I have here? When n is 4, it's 2000. When n is 6, it's 1998. When n is 8, it's 1996. So I think you're taking 2004 and subtracting n from it to get the value of that term. Yeah, that will work, right? 2000 is basically 2004 minus 4. 1998 is 2004 minus 6. 2004 minus 8 gives you 1996. 2004 minus 10 gives you 1994. All right, great. So to figure out our 2004 term, and in that case is 2004. So 2004 minus 2004, and that gives you 0. So all that hard work to get 0. So 12, the answer is C. If f at x is equal to ax plus b and f at negative 1x is bx plus a, with a and b real, what is the value of a plus b? So a very quick primer for you, just in case you don't know about this. If you have any function, right, let's say 3x plus 2, and they want you to find f at negative 1x. Well, what does that mean? Negative 1x. It's the inverse function. And the way you do that is you take your original function right there, write it out as y equals 3x plus 2, and then just flip the x and the y's. So put an x where the y is, and put a y where the x is, like that. And isolate for y, and there you go. This is now your inverse function, and can also be written as f at negative 1x is equal to x minus 2 over 3. Okay? So that's just a little bit of a primer I wanted you to take a look at. So now let's look at our question. Our question says that f at x is equal to ax plus b, and f at negative 1x, the inverse, is bx plus a. All right? Now let's say we were not given this. We could figure out f at negative 1x, just how I did previously with my primer, right? That's wrong. Don't do that. We want to basically figure this out. So how do we do that? Just write y equals ax plus b, where this is my original equation, and then we flip the x's and the y's. So this becomes an x, and where the x is, we put a y, like that. And then isolate for y. And there you go. This is our inverse function, x minus b over a in this case. But they actually give you a value right here. No problem. That basically just means that we have two different forms. So these two different forms obviously are equal to each other, like that. Okay? So that allows us to solve. And we can solve this to cross multiply. X minus b equals abx plus a squared, like that. And I think that's it. And what I'll do is I'll write this out into a little bit of a different form. It's pretty much the same thing. I just wanted to make this a little bit obvious that we have to match coefficients. So the reason I wrote it like that is this one has to be equal to AB, right? That's my first coefficient. And then this minus b has to be equal to a squared. Minus b is equal to a squared. All right? So from the first one here, 1 equals ab, I get b is equal to 1 over a. And therefore, I can now put that into this guy right here. So we have minus b, well, b is 1 over a, is equal to a squared. Cross multiply, you get negative 1 is equal to a to the power of 3. And solving, a must be equal to negative 1. All right? Put that into here, and you'll get 1 over negative 1 is equal to b, and therefore b is equal to negative 1 also. And there you have it. Finally, they want us to figure out a plus b. No problem. A plus b is equal to negative 1, negative 1, and that is therefore negative 2. So number 13, the answer is A. In triangle ABC, AB is 13, AC is 5, BC is 12. Points M and N lie on AC and BC respectively, with CM and CN equal to 4. Points J and K are on AB, so that MJ and NK are perpendicular to AB. What is the area of the pentagon CMJKN? So here's my diagram blown up a bit, and I'm going to start labeling everything they gave us. We know that this is 13. We know that this is 5. And this is 12. And this MC is 4. CN is also 4. And we are told that these are right angles in here. This is a right angle. This is a right angle. And also, since 5, 12, and 13 have a Pythagorean relationship, this is a right angle. Okay? And it's going to be a bit hard for me to squeeze this in, but I think I can. I'm going to call this angle theta, and therefore this angle in here, right there, is 90 minus theta. All right, I hope you can see that. And I think that's it. A couple more things. This angle in here will also be 90 minus theta. And I think that's enough for the labeling, pretty much. Now, one thing I noticed immediately is that we've got a whole bunch of similar triangles here. The triangle ABC is similar to triangle NBK, and that is similar to the very small triangle AMJ. Why is that? Because they all have the same angles. Notice in ABC, which is the big one, right, that big one, you have the following angles. You've got a 90, a theta, and a 90 minus theta, correct? And then in NBK, which is this one, the angles are 90, theta, and 90 minus theta. And in the very small one, it's going to be hard for me to draw, but one of those angles is 90 minus theta, which I squeezed in there. The other angle is basically opposite the right angle, so that's also a right angle. And then the third one, of course, will just be theta, because the sum of the angles are always equal to 180. So since these are three similar, I should say, triangles, their hypotenuses give us a very important relationship. So their hypotenuses are which numbers? Well, for ABC, it's 13. For NBK, the hypotenuse is here, right? Well, this is 12, and this is 4. So that means that hypotenuse is 8. And then for the little guy, AMJ, that hypotenuse is essentially that red line that I just drew. And that's equal to 5 minus 4, which is 1. So I'll just put that in there, 1. So there you go. Those are the ratios of the hypotenuses. And because these are triangles, that means the areas have the ratio 13 squared, 8 squared, and 1 squared. All right, so that is going to help us tremendously in order to figure out this question in a quick way, because there's a longer way. There's always a longer way, but you always want the quickest way on math contests since you're limited for time. All right, so here we go. I don't know the areas yet, but I can calculate some of them, or at least one of them I know I can calculate. I can calculate the area of ABC triangle. Why? Because those length and base, or base and height, have been given to me. Triangle ABC is basically 1/2 base times height. The base is 12 and the height is 5. So this is 12 divided by 2, which is 6. 6 times 5 is 30. So 30 is the area of ABC. Now the area of the shape that they want is CMJKN. CMJKN. So they want this one. CMJKN. That guy right there. Now how do you figure that out? Well, you basically take the total area of ABC. So we want CMJKN. It'd essentially be the total area. Subtract from it the triangle NBK, and subtract from it the very small triangle AMJ. And that will give you what we're looking for. Well, ABC we just figured out was 30. Now NBK, remember, the ratio of the areas has been given thanks to the hypotenuses. So that ratio helps us to figure out NBK. It's basically 8 squared over 13 squared times the area of ABC, like that. And then AMJ, very similarly, 1 squared over 13 squared times the area of ABC, which is 30. So this becomes 30 minus, if you factor out a 30, you'll get 8 squared plus 1 squared all over 13 squared, and get a common denominator here, 13 squared times 30, and this looks like minus 30. 64 plus 1 is 65, like that. 13 squared. Factor out a 30 again, and you'll get 13 squared, which is 169, minus 65, all over 13 squared. And this looks like 169 minus 65 is 104, all over 13 squared. And 104 divided by one of these 13s basically leaves an 8. And that basically makes a 13 on the denominator. And there you go, we got 240 over 13. And that is the final answer. So 240 over 13 would make number 14 equal to D. The 2 digits in Jack's age are the same as the digits in Bill's age, but in reverse order. In 5 years, Jack will be twice as old as Bill will be then. What is the difference in their current ages? So Jack is AB, that's his age. Those are the 2 digits at least. And Bill is BA. Those are the 2 digits in his age. So the numerical value of this is 10A plus B. And the numerical value of this is 10B plus A. Now they're saying that in 5 years' time, if you add 5, Jack will be twice as old as Bill. So if you add 5 to his, then double it, it'll be the same as Jack's. So let's do the algebra here. This basically gives us 20b plus 2a plus 5. And this looks like 8a minus 19b. And then 5 minus 10, which is negative 5. And I think we can isolate for one of these. 8a would be 5 plus 19b, and therefore a is 5 plus 19b all over 8. Now, what do they want you to figure out in this question? They want you to find the difference in their current ages. Well, Jack's current age is 10a plus b, and Bill's current age is 10b plus a. So the difference is when you subtract them. So this will be 10a plus b minus 10b minus a. So this becomes 9a minus 9b. Factor out a 9, you get a minus b. But they actually want a numerical value. As you can see, they're all numbers. So no problem, we can probably substitute that into there and see if that helps us. So this becomes 9a is 5 plus 19b over 8. You get a common denominator, minus 8b over 8. And this gives me 5 plus 11b over 8, like that. And this will be 45 plus 99b over 8. Now, again, unfortunately, it doesn't give us a numerical value, but we can substitute values for b and see what happens. So if b equals 0, right, because b is just a digit, it can be 0. Because, you know, Bill could be a child. There's nothing in the question that says he can't be. But if b is 0, unfortunately, 45 divided by 8 does not give you a integer, right? Because the difference between their ages has to be an integer. No problem. Let's try b equal to 1. Well, that gives me 45 plus 99 over 8, and that is equal to 18. And therefore, that works. They're basically saying that the difference between their ages is 18 years. And that makes perfect sense since 18 is an integer. So 15, the answer is B. A function f is defined by f at z is equal to I times z with the line over it, where I is the square root of -1 and z with the line over it is the complex conjugate of z. How many values of z satisfy both the absolute value of z equals 5 and f at z equals z? So first, let's understand this question. We have f at z is equal to I times z bar, and then I is equal to the square root of -1. And z is a complex number, so it's always going to be of the form x plus yi, like that. That's what complex numbers look like when they're written out. And z with the bar over it is the complex conjugate, and the conjugate is x minus yi. Okay? Now let's look at the conditions here. The absolute value of z is 5. That means really what they're talking about is the distance is 5. So that means that x squared plus y squared, the square root of that is equal to 5. Or if you want to get rid of the square root, x squared plus y squared is equal to 25. Okay, that's what that means. And then we take care of that guy, and let's look at this one. F at z equals z. F at z is equal to z. Well, z is right here, x plus yi. So x plus yi. And f at z is here. It's I times z bar, which is the conjugate, complex conjugate. All right, let's see what this makes us in terms of an equation. I times z bar, which is the complex conjugate, so substitute that in. X minus yi, don't forget brackets there, is x plus yi. Multiply through the I and you get xi minus y times I squared is equal to x plus yi. And I squared, since I is the square root of -1, I squared is -1. So you get xi minus y -1 is x plus yi, like that. So this becomes xi plus y is equal to x plus yi. So after all that, this is what we came down to. Now, xi plus y is equal to x plus yi. Now, the only way this can possibly be true is if x is equal to y. That's the only way that can work. And if it does equal, you would get basically xi plus x is equal to x plus xi. And as you can clearly see, that is equal. So now we go back to the question. What is the question asking? How many values of z satisfy both of those? So we want to figure out when is this true and this true, right? Okay, that shouldn't be a problem if we put it on a graph. So we'll put it on a graph, x and y, and let's see what we get. X squared plus y squared equals 25 represents a circle that has a center at the origin and a radius of 5. So that's what I drew right there. I'm going to put 5 there. Like that. And then this right here, x equals y, well, you definitely know what that is. That's just a straight line going through like that. And they want you to figure out when are both of these equations the same. Well, what that really means is where do they intersect? Well, they intersect at those 2 points. And that's basically what they're asking. How many values of z satisfy both z absolute value is 5 and f at z is equal to z? And the answer is 2 values. The first value is right here. The second value is right there. Okay? The points of intersection represent the number of values. And we don't need to actually figure out what those values are. We just need to know how many. So 2 points that satisfy both equations, also known as their points of intersection. And therefore, number 16, the answer is 2, which would be choice C. For some real numbers a and b, the equation 8x to the power 3 plus 4ax squared plus 2bx plus a is 0 has 3 distinct positive roots. If the sum of the base 2 log of the roots is 5, what is the value of a? So let's say our roots are r1, r2, and r3. They are saying that the sum of the base 2 logarithms of the roots, like this, log of r1 to the base 2, log of r2 to the base 2, plus the log of r3 to the base 2, is equal to 5, right here. Okay, using our log rule, since the bases are the same, this becomes r1 times r2 times r3, and that is equal to 5. And therefore, the definition of log gives us 2 to the power of 5 is equal to r1 times r2 times r3. Now, where do we go from here? So far, we're doing great, but it seems like we're kind of stuck, right? Well, not really. Remember, there's a rule. If you have any polynomial of the form ax to the third plus bx squared plus cx plus d, the sum of the roots, if you remember, is minus b over a, where this is b and that's a. And the product of the roots, which is what we need in this question, is d over a if it is an even degree polynomial, and d over a negative if it's an odd degree polynomial. Now, our polynomial is x to the third, which is an odd degree. So we're going to use this equation. So the product of the roots, which is exactly what we have right there, is minus d over a. But be careful, d in our case is what? Right there. So we have a, minus, like that. And a in our polynomial over here is equal to, right there, 8. So minus a over 8. That's how you would figure that out. And 2 to the 5, of course, is just 32. So therefore, solving for this, we get 32 times 8, which is 256. Put the negative over that side, and there you go. A is equal to negative 256. So number 17, the answer is A. Points A and B are on the parabola y is equal to 4x squared plus 7x minus 1, and the origin is the midpoint of AB. What is the length of AB? So we've got this parabola, and I don't really know what the parabola looks like, so I'm just going to draw a sketch, very rough sketch here. Maybe something like this, okay? And they're telling us that there's 2 points on this parabola. So we have a point here, perhaps, and we have another point here. And when you draw a line between those 2 points, the line passes through the origin. So something like this. And they tell you that the origin is actually the midpoint of that line. So if this is A and this is B, that origin, which is of course 0, 0, is the midpoint of that line. So let's start labeling this. A, let's just call it AB. I don't know the coordinates. And B, again, I don't know the coordinates, so I'll just call it CD. But since 0, 0 is the midpoint, the origin is, it's very helpful because you can say that 0, 0 is the midpoint of A and B. That means A plus C over 2 and B plus D over 2. That's how you calculate the midpoint of 2 points, right? You add them, divide by 2. So from the first one, we get that A plus C over 2 is equal to 0. That means A plus C is 0. Therefore, A is equal to negative C, or C is equal to negative A, whichever way you want to write it. And then from the second one, we get that 0 is equal to B plus D over 2. And therefore, 0 is equal to B plus D. And therefore, D is equal to minus B. So this CD we can essentially write as minus A and minus B. All right, so here you have AB, here you have minus A minus B. So that's the first part of the question. Now we are interested in finding out the length of AB, right? Okay, we've got 2 points, kind of similar, but we need numerical values, right? Because the answer choices are all numbers. A and B is not going to cut it for us. Okay, no problem. One thing that we know is that both of these points A and B are on this parabola that they gave us. So we can substitute that in. First, let's start with point A, which is AB. It's on that parabola, and that parabola is y is equal to 4x squared plus 7x minus 1. So substitute our point AB. We get B is equal to 4a squared plus 7a minus 1. All right. It's about as far as I can go there. Now let's substitute our B point, which we figured out was minus A minus B. Let's put that into the same parabola because it's also a point on the parabola. And this will give me minus B is equal to 4 minus A squared plus 7 times minus A minus 1. All right, so those are my 2 equations, and let's see what I can do to solve. I can add them. I can add this and that. So the left side would become B minus B. I'm adding. The right side would become 4a squared plus 7a minus 1 plus 4a squared, it looks like, minus 7a minus 1. So this looks like 0. 8a squared. The 7a's cancel, and minus 1, it gives me minus 2. Okay, So bring the minus 2 over, you get 2 is equal to 8a squared, and therefore a squared is equal to 1/4, and a therefore is equal to 1/2. Substitute a equal to 1/2 into any one of these to get our value for b, and you get 4 times 1/4 plus 7 times 1/2 minus 1. And this looks like 1 plus 7/2 minus 1, and therefore b is 7/2. Okay, so now we're set. Now we know a and b, we can find the distance. The distance between 2 points, if you remember, our 2 points, first of all, are a, b, and minus a minus b. Well, we know the a and b values. It's 1/2 and 7/2, and minus 1/2 and minus 7/2. The distance between 2 points, you remember that formula. You subtract them now, so it would be 1/2 minus 1/2 all squared plus 7/2 minus 7/2 all squared, and of course you have to take the square root of that whole thing. So this looks like 1/2 plus 1/2, which is 1, so 1 squared, and then 7.5 plus 7.5, so that looks like 7, so 7 squared. And this is 49 plus 1, so 50 under the square root sign, and that's 5 times, or 25 times 2, that would be better. 25 times 2, and then you can take out the 5, and this becomes 5√2. So that's the distance between those 2 points, 5√2, and therefore number 18 is E. A truncated cone has horizontal basis with radii 18 and 2. A sphere is tangent to the top, bottom, and lateral surface of the truncated cone. What is the radius of the sphere? So here is our truncated cone. And as you can see, the black lines represent the horizontal bases, and I extended the diagram a little bit because I'm going to need that to solve this. And then I'm going to just draw one line from the center of that sphere to the tangent point right there. Okay? And I think that should be enough in terms of lines, but we'll see how this goes. All right, let's start filling in what we know. What we don't know, we'll put a variable. The biggest variable, of course, is the radius of the sphere. That's what we want to figure out. So this is r, this is also r, and this is also r right here. Now the radii of the horizontal basis they give us, that's 18, and this down here is 2. And then this distance from here to here, I don't know, so I'll call that x. And I believe the height of the cone before it was truncated was not given to us, and that's this whole height right there, and I'll just call that h. And therefore this right here is h minus x. Okay, and I think that should be it, but if it isn't, we can always go back. Tangents, of course, give us right angles, so this is a right angle right here, this is a right angle right there. If this is, say, theta, then this is going to be 90 minus theta, correct? And then this is, of course, another right angle, and this is 90 minus theta in here. So that gives us some relationships, similar triangle relationships, if we need them. We probably will. So now let's go ahead and figure out what we can with our relationships. The first, of course, is this triangle, little guy, and the big one. Those are definitely similar. So that tells me that 2 over x is equal to 18 over h. All right? And from that, we quickly get that 2h is equal to 18x, and therefore h is equal to 9x. All right, and then this h minus x is the same as 2r. There's no similar triangles needed for that. That's just by observation, basically. So h minus x is equal to 2r. All right? Now, I'm going to try to get everything in terms of r because that's what I want to calculate. So I'll put this into here. I've got 9x minus x is equal to 2r. And therefore 8x is equal to 2r. 4x is equal to r. Like that. Or x is equal to r over 4. Okay? And then now we have to figure out a relationship between two similar triangles. And before I do that, I'll just make h in terms of r. 9 times r over 4. Right? Might as well. Okay, now let's figure out that relationship. It's going to be the following triangles. This triangle here and the big one right there. Okay? So before I do that, I probably just need a little bit of labeling here. Call this A and B and C. Not too much. And then that relationship between those two triangles, this one and the big one, is as follows. In the smaller one, we have r over r plus x, right? This is r, and this is r plus x right there. And in the big one, it will match up to 18 over that whole hypotenuse. So 18 over BC. Okay? And isolating for BC, you will get that BC is equal to 18 times r plus x over r. All right? And then now we've got one final step, and that is figuring out r. And we can do that with Pythagorean theorem on the big triangle right there. So that's AB squared plus AC squared is equal to CB squared, like that. AB squared is 18 squared. AC squared is H squared. And CB squared, we just figured out right here. CB, BC, same thing. 18 r plus x all over r, all squared. All right, so let's do the math now. So 18 squared, I'll just leave that alone for now. H squared, I'll put it in terms of r from here. That's 9 squared r squared over 4 squared. And this one in here is going to take a little bit of simplification. 18 r plus x, x is r over 4. All over r, all squared, like that. Okay, so this is the equation that will help us figure out r. So let's see what we have here. We've got r over 1, r over 4. That will give me 5r over 4 times 18 over r, all squared. And that gives me 90r over 4. Invert and multiply, and it'll be 1 over r, all squared. And the r's cancel, so that just makes 90 squared over 4 squared. Okay? And then over here, I've got 18 squared plus 9 squared r squared over 4 squared. So very quickly, it kind of simplifies. Get a common denominator, 4 squared on that guy. And then the denominators we can just cancel. And then we're just left with 4 squared, 18 squared, like that. And 9 squared r squared is equal to 90 squared. Okay? Put the numbers on one side. 4 squared, 18 squared, like that. And then remember, if you have a squared minus b squared, That's the same as a minus b times a plus b. So this becomes, if you factor it out like that, 90 minus 4 times 18 plus 4 times 18. And this is just 9 squared r squared. So this one here, 90 minus 4 times 18, it looks like 18. And then 90 plus 4 times 18 is 162. 9 squared. I'll put the 9 squared in the denominator, might as well. And then we're almost done. The 18 will cancel out with one of the 9s, so that becomes 2. And this becomes 81 times 2. And therefore 81 divided by 9 is 9. So I've got 9 times 4 is r squared. And therefore r looks like 3 times 2, which is 6. And there you go. I did it a little bit differently because you're not allowed to use a calculator, right? So instead of creating these huge numbers and trying to figure out that in your head, just leave them as squares and eventually they all cancel out like that. So the radius of this sphere is 6. And number 9 is therefore, number 19 I should say, is A. Each face of a cube is painted either red or blue, each with a probability of a half. The color of each face is determined independently. What is the probability? That the painted cube can be placed on a horizontal surface so that the 4 vertical faces are all the same color. So you've got this cube and it's sitting on a horizontal surface, and they basically want you to make sure that all the vertical faces are all the same color. So for example, if this is red, that's red, the one behind is red, and the one on the side is red. The top and bottom, they don't care. What you put there doesn't matter, as long as the 4 vertical faces are the same color. So let's figure out how many ways we can do this in. There's 3 scenarios really. The first scenario is when they're all the same color. And if they are all the same color, that means they can all be either red, 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 like that, or they can be all blue. Because they don't really care about what goes on the top and bottom. As long as 4 that are representing the vertical faces are the same color, the condition of the question is satisfied. All right? So that's the first scenario. The next scenario is when they're all the same color except one. One is a different color. And that scenario is, for example, if you have 5 reds and you have 1 face that's blue. What you can do is you can put the blue up top and then you can just put the reds everywhere else. And it satisfies the condition. As long as you take that one blue side and put it either on the top or on the bottom, the condition of the question will be satisfied. So how many ways of doing that is there? Well, there's more than one. You can put the red guy everywhere except one face. And that one face can be any of the 6. So I'll just write them out. There's 6 possible ways of doing that. So basically that type of a scenario. And in a very similar way, you can do the exact same thing, but this time where blue is the dominant color. So as follows. So here you go, the exact same scenario, but this time only one side is red, all the others are blue. So any one of those you can place on the cube and make the red side either the top or the bottom, and the remaining sides will basically meet the condition of the question. And the final scenario is, in my opinion, probably the trickiest one, and that is when you have 2 different colors. And what that means is that 2 of the sides are a different color. So for example, you have blue, 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 4 of them, which is what you need, and the other 2 are red, like that. That way you put red here, red on the top and bottom, and the blues will be the 4 vertical faces, correct? And then the other scenario where red is the one that has the 4 vertical faces, and then blue are the other ones. Now, this is the part that I think is a bit tricky. You think, okay, well, that's fine. Let's count them up and divide by the total and move on, right? But this one here, there's 3 ways of doing that. You say, well, I don't get it. How is it 3 ways? I don't understand. There's only one way. Well, I'll explain. The first way, I actually just drew it here. The red goes on the top, red goes on the bottom. The other sides are blue, right? The other way is if you take a different approach. You put the red here, and you put the red here. And then the blues go, obviously, the other 4 faces. And I say, well, that doesn't fit the criteria of my question. 4 vertical faces have to be the same color. This is not 4 vertical faces. You put it on the top and the bottom. Yes, that is true, but I can flip the cube. I can make this red the bottom. See what I mean? And that will therefore fulfill the criteria of the question. And in a very similar way, I can do the same thing by putting the red here and the red back there. All the other sides will be blue, but then I can make this guy the bottom by just flipping the cube, turning it. See what I mean? So I think that was probably the hardest part about this question. So there's 3 ways of doing that and 3 ways of doing this. So here we had 2, here we had 6. These guys, there was 6 here. So in total we got 2, 6, 6, which is 14, and 6, we got 20. 20 ways, and the total ways, of course, you got 6 sides. 1, 2, 3, 4, 5, 6. For each, you've got 2 color choices. 2, 2, 2, like that. And you just multiply them to get the total number of combinations. And this is 2 to the power of 6, which is 64. So that's the denominator in our probability question. So 20 over 64 is the answer. In lowest terms, that's 10 over 32, 5 over 16. So for this question number 20, the answer is B.